Hello and welcome to Solved Papers channel. I am Godfrey. In this video, I will be solving questions on Cambridge as chemist on topic carboxylic compounds. These questions are from October-November 2019 exam series. I prefer doing topical questions, and I urge you to consider doing your revision topic-wise. Read your notes and your textbook on a given topic, and when the content is fresh, come and attempt questions that will be set on that particular topic for several years, 2019, 2018, going backwards. In this way, you will be exposed to the key areas the examiners are fond of testing, and you will get to know how to answer the questions on a given topic. I urge my students always to go topic-wise, and this has never backfired on any one of them. This is a sure way of getting your A star. Well, if you have not already subscribed to my channel, please click the subscribe button and hit the bell icon below. This way you will be notified every time I upload a new video. Also consider sharing these videos with your friends if you find the videos useful. Let's get started with number one. In all my questions, you will find that I've indicated to you this in every question. This is indicating 9701, that is the code for chemist examination in Cambridge. Then 11, this is the variant. In AS, we have paper 1, paper 2, paper 3, and paper 3. Of course, 11, 12, 13, those are multiple choice. Then paper 2 is a structured question. Paper 3 is a practical paper. ON basically means October, November. 19 here is 2019. And this is the number of the question on this paper 11. So this helps you to refer your past papers or your marking schemes if so you wish. So every question in this paper, you can easily refer to whatever past paper you need, and that's why I've given that in every question. Well, let's look at what number one is saying. Alcohol X is oxidized to form compound Y. Okay, alcohol X is oxidized to form compound Y. The composition of Y is 54.54% carbon, 36.36% oxygen, and 9.10% oxygen. The MR of Y is 88.0. What could be the structure of alcohol X? We are given the MR of Y, and you are given the percentage composition of compound Y after that is obtained when alcohol X has been oxidized. So to find this, we first need to, because we are given these percentages, we need first to find the empirical formula for compound Y, right? To do that, just go ahead and go the usual long method. 54.454% is carbon, 36.36 is 9.10 is hydrogen, 36.6 is oxygen. Of course, we divide each one of these by its AR, relative atomic mass. For oxygen is 16. When you do that, you get 4.545. Use your calculator. Of course, this one you get 9.10. This one you will be able to get 2.0 2725. Of course, the least of these is 2, so you divide every one of these by 2.275, divide by 2.275, divide by 2.2725. This is 25. This is 7 to 5. Of course, once you divide nicely, what you'll get here is you'll get 2. Here you'll get 4. And this one here you'll get 1. And therefore, the empirical formula is equals to C2H4 and 1 oxygen. When you find the MR of this, if you find the MR of this, you're going to be getting 12 times 2 for carbon, plus 4 times 1 for oxygen, for hydrogen, plus 16 for oxygen. What you'll get is 44. But we are told here the MR of Y is 88. So MR is equals to N times empirical formula. So what is N? N is equals to MR divided by EF, which is going to be 88 divided by 44, which is going to be 2. And therefore, the molecular formula of this compound is 2 times C2H4 oxygen, which will give us 4 carbon atoms, 8 hydrogen atoms, and 2 oxygen atoms. So most likely compound Y is a carboxylic acid, since it has got 2 oxygen. So compound Y is a carboxylic acid. Okay, so alcohol X, from where we are getting compound Y when alcohol X has been oxidized, so alcohol X must be a primary alcohol, must be a primary alcohol with 4 carbon atoms and 8 hydrogen atoms okay, and 1 oxygen atom. Therefore, when you come to the multiple choice, you notice that for air, this is air. This is a secondary alcohol. That is a secondary alcohol. B, of course, OH is attached to the end of this carbon atom, so this is a primary alcohol. C, you can check, this is also a primary alcohol. And then lastly, D, OH is attached to this carbon, so the carbon attached to this OH is attached to 2 other carbon atoms, so that is a secondary alcohol. So we are dealing with C and B. Okay, now how many carbon atoms does B have? We need an alcohol with 4 carbon atoms, so 1, 2, 3, 4, 5. So B has got 5 carbon atoms and therefore cannot be B. How many carbon atoms does C have? 1, 2, 3, 4. So the right answer is C. The right answer is C. So X is butanol. but1 ol. X is but1 ol. Very well. Question number 2. Question number 2 appeared on variant 1.1. Question number 28 on paper 1.1. Tartaric acid, this formula here, is found in many plants. A sample of tartaric acid reacts with an excess of lithium hydrate, aluminum hydrate, to form the organic compound J. Of course, this is a reducing agent. What happens to sodium hydroxide? What happens when sodium hydroxide is added to separate samples of tartaric acid and compound product J, which is obtained when tartaric acid is reduced? As I've said, this lithium aluminum hydrate reduces. This reduces the carboxylic acid, carboxylic acid to a primary alcohol. Right? Remember, when primary alcohols are oxidized, you get a carboxylic acid. When you reduce a carboxylic acid, you get a primary alcohol. So the carboxylic acid, just write C for acid, carboxylic acid. Carboxylic acid will react, okay, with the sodium hydroxide, reacts with the sodium hydroxide to form salt and water. Of course, to form salt and water, okay, only. And the alcohol, which is the tartaric acid, the alcohol will not react with sodium hydroxide, which is obtained when tartaric acid is oxidized. So alcohol, which is basically J, alcohol J will not react with sodium hydroxide. So then, of course, you can see both tartaric acid and J reacts. This is not correct. We have said alcohol J will not react with sodium hydroxide. Only tartaric acid reacts. Of course, we have said it will react, and what you'll get is an alcohol. Only J reacts. This is not correct. Neither this, okay. That is also not correct. So the right answer there is B. It's great you're watching this video, but remember, practice makes perfect. I encourage you to practice working out these questions yourself as I guide you through. You may get this same paper I'm solving right now from this site here, solvedpapers.co.uk. I may help you and get you to the site. This is the site I'm talking about, solvedpapers.co.uk. It's a very resourceful site. You need to come here. Chemist, monthly 2019 AS topical. Of course, I need you to get here. You can get all the topicals right here. This is 2019 November, multiple structured as well. You can also get June, same multiples and structured. Right now I'm tackling this question here, carboxyl groups. You can go there and basically download that. And of course, if you want all of these, which I recommend you get to, you can click over here. You'll be brought into this page whereby you can get either all 2019, 2018, 2017, 2016, but you're in 2019, you can get, of course, AS is right here. AS is right here. You can see, of course, you can request your parents to acquire these papers for you. They are well premiumly priced, just £9. Of course, can get for all the years. And practice is the key. If you want your A star, you must put in the works, and of course this makes it easier for you. You can get all of them at a discount if you so wish, and you will be good to go. That has been having said that, let's go to question number 3. Question number 3: when it's a compound that has got 2 functional groups, the alcohol functional group and the acid functional group, which basically gives the impression it's an amino acid. When this one is warmed with a little concentrated sulfuric acid, a cyclic compound is formed. What is the skeletal formula of the cyclic compound? Of course, we know that carboxylic acid, this carboxylic acid will dehydrate the alcohol part, or the alcohol functional group. So if I may write the formula here in a displayed formula, this one then goes to, there's no double bond, it's one single bond, but double bond is there. And we have hydrogen, we have the carboxylic functional group there. So the carboxylic acid will dehydrate this by picking this and this OH here and this H here. Okay, dehydration is basically removing the water molecule from this compound. And when that happens, of course, what you're going to be remaining with is how many carbons? 1, 2, 3, 4. So 4 carbon atoms with a carbon double bond oxygen. Then you can come to this carbon here, this carbon with hydrogen. Then you go to this carbon here with a double bond right here. So this carbon here is with a double bond right there. Then you go to the other carbon up here, just got 2 hydrogen atoms right there. And then of course this carbon here will bond to this oxygen. So you have that oxygen which is bonded to that. So this is the kind of course this one has got some hydrogen here, kind of structure that you'll come up with. So among all these structures, which one resembles this structure? Of course, can draw a simplified form of this structure. So hydrogen there, this is a double bond there, that and that. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is that. So the compound which resembles this is C. Compound that resembles this cyclic structure is C. So the answer is C right there. Question number 4. Question number 4 is still on paper 1-1. This was question number 37. Okay. The structure of Ticklic acid is this one. The structure of Ticklic acid. Which statement about the properties of one molecule of this acid is correct? Right? We are told it has 2 pi bonds. We are going to confirm that. It contains 4 lone pairs of electrons. It has all its atoms in the same plane. So let's draw a displayed structure of Ticklic acid. Okay, so let me draw it here. This is hydrogen, followed by another carbon here with a single hydrogen there, and a double bond. Okay, we have this. Then it has a branch of another carbon right there with 3 hydrogen atoms. Then we have the carboxylic acid end right there. Alright, we are told it contains 2 pi bonds, and of course one of the pi bond is here. This is a pi bond. Okay, that's a pi bond. So we have another pi bond. Yes, we have another pi bond here. This double bond. So another pi bond. We have this oxygen has got 2 lone pairs of electrons. It's got 2 lone pair of electrons, and this other one here also has got 2 lone pairs of electrons. So the 2 oxygen atoms have got 4 pairs of electron. 1, 2, 3, 4. So you can see that the 2 oxygen atoms have 4 pairs of electrons. Okay, we see that. This is a branch here. This is a branch. So all the atoms are not in the same plane, because there is a branch. So atoms are not in the same plane. This branch. Due to the branch, all atoms not in the same plane. Then you can see that the double bond have got 2 pi bonds. So the 2 double bonds of 2 pi bonds. So one is correct. It contains 4 lone pair of electrons. That is correct. This one is not correct. So the correct answer here is 1 and 2, which happens to be B. So B is correct right there. Okay, of course these are lone pairs of electrons. Very well. So that's the answer to that question. Number 5. Which compounds on heating with excess concentrated sulfuric acid produces only one product with the molecular formula this? Which compounds? Compound 1, 2, or 3. You heat it with excess of concentrated sulfuric acid. What will it give? Which one gives the molecular formula, a compound with the molecular formula this here? We know that alcohols, when they are dehydrated by sulfuric acid, give alkenes when dehydrated by sulfuric acid, liquid conc. So we have the functional groups in these compounds are all they are called functional groups, and therefore in this case we will have in this first compound, when it is dehydrated by sulfuric acid, what you're going to be getting is that this will be this group will be snatched, and this alcohol and this hydrogen here, to get the molecule of water. So when that is snatched, then of course we'll have a double bond here and another double bond here for this oxygen. So what we get here is this compound here. We'll get a compound like this when this compound is dehydrated. Get this kind of a compound. Let me draw a bigger one, a smaller one. That compound there. This one, when it's dehydrated, of course, you're going to get this compound here. Let me draw this arrow to get this compound right here. And then for 3, this one gives 2 compounds, right? For 3, it gives 2 products. Okay, of course the first product will be this will give this. We'll give this product here first. Give that product, or it will can also give this product. That product right there. All right, so this product and these products are obtained from this. So you can count the number of carbon atoms for each product and see which one has got this formula right here. And of course, for product 1, you'll get how many carbon atoms? 1, 2, 3, 4, 5, 6, 7. Okay, so that has got 7 carbon atoms. How many hydrogen atoms do we have? Of course, these carbon atoms here will be bonded to 2 carbon atoms. And so the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 hydrogen right there. What about this other compound here, compound 2? How many carbon atoms does it have? 1, 2, 3, 4, 5, 6, 7. So 7 carbon atoms. How many hydrogen does it have? This carbon here will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Likewise, it will have 10 hydrogen right there. And then of course this compound here is similar to this compound here is basically similar to this compound. It's only that is only changed. So this one, you can also say it has got 10, 7, and 10. What about this one? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 7 carbon atoms, hydrogens. How many? This one was 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. So they all seem to be having the same number of hydrogen and carbon atoms, which is not in the answer here. Yeah, this answer A. So which compound on ET with an excess concentration will produce only one, all right, product with the molecular formula this. So 3 is produce E2. Okay, 3 is produce E2, and therefore we only needed 1. Okay, so the right answer is 1 and 2, which is the answer is B right there. Number 6. Number 6, and before we get to number 6, I'd like to let you know that I do online tuitions. I've got online tuition classes on a website called spacademy.co. spacademy.co.uk. What am I writing? .co.uk. And the site I'm talking about is this site here. This is SP Academy. SP is short for Soft Papers Academy, with a collaboration of teachers teaching premier schools who are doing this to help students and help them get to their desired grades. So I'd like you to visit this site if you find time. The kind of courses we are offering is subjects we are dealing with. It's ICT, mathematics, physics, biology, and chemistry. Of course, you can have a look at this, but I would like you to check the step-by-step guide as you sign in. You can also have a look at this video here to get familiar with the online live classes. Of course, I need you to come to log in and create an account. Of course, you need to register, select group, student. Then, of course, you provide the correct email, because we will send you an email which you will need to activate your account with. Then you can log in, and once you're logged in, you go to your dashboard. Then you can find a tutor of your choice and engage the tutor to help you as you prepare for your exams. Try us, and I guarantee you you will discover a great opportunity of getting very outstanding grades. Well, I hope to see you in my tuition classes. Rest number 6. Number 6 was it's a question that appeared in paper 1-2, and this was question number 24. Number 6, propan-1-ol, which is an alcohol, can be reacted with acidified potassium dichromate to form propanoic acid. Acidified potassium dichromate is an oxidizing agent, so it will oxidize propan-1-ol to propanoic acid. All right. Of course, that is going to be reaction 1, or propanal in reaction 2. This is propan-1-ol. So how can the reaction be carried out to ensure that the reaction 2 occurs rather than reaction 1? Of course, for us to get only aldehyde, this is an aldehyde. To us to get only the aldehyde, then we'll have to distill it from the mixture immediately after it has been formed. Otherwise, the aldehyde will be further oxidized to carboxylic acid. So if we want aldehyde alone, because that's what the question is saying, how can the reaction be carried out to ensure that reaction 2 we only get aldehyde when we oxidize propan-1-ol using potassium dichromate? Then if we need aldehyde alone without propanoic acid, then we need to distill off. So it's not adding excess of this, it's not adding that, it's distilling. So we need to distill the mixture. Reaction mixture is distilled immediately after mixing. All right. Of course, the reaction mixture is heated under reflux. When you heat under reflux, you'll be ending up with the carboxylic acid right there. Right. So that is the answer to question number 6. Number 7. Question number 7. What is the smallest amount of oxygen molecules needed for complete combustion of 40 grams of methanol. 40 grams of methanol. Of course, when methanol reacts with oxygen, this is methanol. When methanol reacts with oxygen, what you get is this is going to be 2. What you get is carbon dioxide and water only. Carbon dioxide plus water. Okay, 4 molecules of water. So, to get to know how the smallest number of amount of oxygen, of course, you can see the mole ratio here is 2 to 3. 2 for methanol and 3 moles of oxygen. We need first to find the number of moles of methanol that are in 40 grams. And to do that, first we get the MR of methanol. When you calculate nicely, you find that the MR of methanol is 32. So moles of methanol in 40 grams, moles of methanol in 40 grams will be mass divided by MR, which is 32. And when you do that, you'll get 1.25. 1.25 moles. 1.25 moles of methanol. Now, we have said that the mole ratio is 2 to 3. So, since the mole ratio is 2 to 3, then we have 1.25 moles of, let me just write it clearly here. This is methanol, and this is oxygen here. So the mole ratio is 2 to 3. So we have 1.25 moles of methanol. How many moles of oxygen will we have? Okay, you can cross multiply. You find 1.25 times 3 divided by 2. This will give us 1.875 moles of oxygen. Right? So then the smallest amount of oxygen that will be needed for complete combustion of this will be this number of moles, 1.875, which is approximately 1.88 moles, which is the answer A there. Number 8. Number 8 is from the same paper 1-2, paper 1-2, and this was question number 28. If you need to refer, esters can be prepared. Esters can be prepared by a reaction of carboxylic acid with an alcohol in the presence of concentrated sulfuric acid as a catalyst. Which row gives the correct names of the reagents that would be suitable to prepare ester Z? To prepare ester Z. Of course, you can write this one in a displayed structure if you want to see the whole atoms participating. So we have that, we have this, we have this, and then we have that, oxygen there, then we have carbon there, we have CH3, we have another CH3 there, we have hydrogen right there. So the alcohol part is this one. That is the alcohol part, and you can see this alcohol part is got 1, 2, 3, 4. So this was butanone. This was butan 1. Butan 1. This is just butanoic acid. Butanoic acid. And then of course the alcohol is this part here without the OH that has been displaced. So this is going to be propan 2. This is 1, 2, 3. So the OH will be attached to this whatever here, carbon here. So it will be this compound. If you can just draw the alcohol along here. So the alcohol will be this, that, and this is propan 2 all. So the acid was, because we are giving, which row gives the correct names of the reagents, the acid and the alcohol, which would be suitable to produce ester Z. And therefore the acid was butanoic acid and the alcohol was propan 2 all. And therefore that means propan 2 all for the acid, and then now the answer is C. That is how you get that. Number 9. Number 9, the compound Q can be hydrolyzed by acid, HCl, aqueous. The two products of this hydrolysis have the same empirical formula. The two products have got the same empirical formula. What could be Q? What could be Q? Of course, hydrolysis is breaking the bond of an ester to get back your alcohol and your carboxylic acid, right? I can see we have an acid here. This acid is this one here. This is an ester. This is 2. This is an ester here. And therefore, when hydrolysis is done by an acid, of course, this will break, and you'll get the products that you'll get will be this acid and this alcohol here. Okay, so do these have the same empirical formula? Of course, how many carbon atoms? 1, 2. This will be C2. Hydrogen, how many? 3, 4, and 2 oxygen. What about this one? 1, 2. So C2. Hydrogen, how many? 1, 5, 6, and 2 oxygen. Of course, this is different. So the empirical formula here will be CH2O, and this will be CH3O, which are not correct, which are not the same. So A is not correct. We go to B. B will be CH3. This, that, draw the ester there. CH2. CH2 here. CH2. We have another acid here. Okay, so when the hydrolysis of this will happen, of course the bond will break there. So what we'll get is CH3 and OH plus OH plus OH, C2, that. So what is the this is the molecular formula here. This is 2 carbon atoms, C2, 4 hydrogen atoms, and 2 oxygen atoms. What about this one? How many carbon atoms? This is 3. This is 3 carbon atoms. Hydrogen, how many? 1, 3, 5, 6. And oxygen are 1, 2, 3. 3 oxygen. The empirical formula of this one, of course, I should have mentioned this is the empirical formula. Sorry, not that. This one there. Empirical formula there. Empirical formula there. So the empirical formula here will be, we divide by 2, you get CH2O. The empirical formula here will be, we divide by 3, CH2O. And these 2 empirical formulas are the same. So we were told that the 2 products of this hydrolysis have got the same empirical formula. Therefore, B is the correct answer. Number 10. Number 10. Which reagents, when used in excess, can convert Y into X? Can convert this into this, right? So we are converting amino acid, right? This is an amino acid, H3CH, HO. That's an amino acid. It has got 2 functional groups, and this is a salt. Z is a salt. Z is a salt. Sodium salt there. Okay. So sodium will always react with the when you consider, if you consider it sodium will react with both the functional groups, will react with the alcohol and the acid functional group for Y. Therefore, the sodium, if it is sodium, what you'll get is a compound which a product which looks like this. When sodium reacts with Y, the product will be this. This will be the product. All right. Which reacts when used excess will convert Y into Z. So this is not definitely Z. So it cannot be sodium. Okay. So basically, when you react an acid with sodium carbonate, you'll get a salt. The sodium carbonate will not react with the alcohol functional group, and likewise, sodium hydroxide will also only react with the acid end to give us this, to not react with the alcohol group. So only sodium carbonate and sodium hydroxide will give Z. Right, you can give an example here for sodium hydroxide. So H3C CH or H say this is Y. When it reacts with sodium hydroxide, what you get is H3C CH. the alcohol part functional group will be intact. Then what we'll get is this plus sodium, then plus water. So you'll get Z. This is Z. Of course, when you react sodium carbonate, you'll get Z plus carbon dioxide plus water. Therefore, the correct answer will be C. Very well. That is, those are the questions that were set on carboxyl compounds for 2019 October-November exam series. Hope this has been of help to you. I encourage you to subscribe and share this video with your friends if you found it useful. Cheers. See you in my next video. Bye.